Hello there. Greetings, everybody, and welcome back. So, thank you for tuning in again. So, we're going to get into lesson 3. Okay. So, in this lesson, I want us to look at a couple of things. Okay. Well, the first thing we're going to look at in this lesson is the limiting reagents. Okay. And then excess reagents. Percentage yield. Percentage yield. Percentage purity. Percentage purity. Empirical formula. And molecular formula. Molecular formula. Okay, so these ones here, they're the same as what? They're the same as grade 10. Okay, so if you still remember from grade 10, then you won't have problems here. Okay, so these are the 6 things that I want us to get into. Okay, the limiting and the excess reagents. So how do you determine the limiting and the excess reagents? So let me just start by the definitions. Okay, so what is a limiting reagent? What is a limiting reagent? Okay, so a limiting reagent, this is a reagent or you can say reactant. A reactant that gets a reagent that gets completely used up. Used up in a chemical reaction. So it gets, so what happens is that a limiting reagent, when there is a chemical reaction, this is a reactant that gets finished first. So it's the one that limits the reaction. And then an excess reagent. an excess reagent. This is a reagent or reactant that does not okay that is not completely used up in a chemical reaction. So what that means is that after a reaction, the excess reagent is the one that is left, is the leftover. You can think about it as a leftover, for simplicity. An excess reagent, you can also say, is a leftover. So it is left over after the reaction is complete. Okay. And then the percentage yield, okay. Percentage yield here is actually, you have to calculate, okay. So it's theoretical yield, and then we have to multiply by 100. So it's actual yield. So it's actual yield divided by theoretical yield, then multiply by 100. Then we also have percentage purity. Then the formula for percentage purity is, so mass of sample so also we multiply by 100, then mass of compound. So we take the mass of a specific compound and we divide by a mass of the sample. So the sample here will have more than one compound. So it'll be a lot of compounds inside the sample. Okay. So and then we come to and then we come to empirical formula. The empirical formula. So now for the empirical formula, well, there is a table that you need to know. So the definition, what is the empirical formula? The empirical formula is the simplest whole number ratio of atoms in a compound. Of atoms in a compound. Okay. So this is the definition for empirical formula. So you need a table, isn't it? Here, we have a table that we use to determine the empirical formula. And the table has 4 columns, okay? And I want to show you here. And the columns are as follows, okay? So it's the element, the first one, and then there is G over 100G. So this is the percentages, they go here. And then from there, we have the number of moles, which we say mass divided by molar mass. And the last column is the simplest ratio. The simplest ratio. Okay. So we write down all the elements that we have in the first column. And then the percentages are written in the second column from the left. Okay, so the elements come here. The elements that you have in that sample, all of them. And then after here, we come here, we write down the percentages. And then we use those percentages to calculate the number of moles. And then after that, we're going to find the simplest ratio. So I will show you. We show you there. When we're doing an example, I will show you how it goes because the percentages are given here, okay, in many cases. So, and then we go to them. So this is the table that we use, and this table is not given in the exam, isn't it? You should know this table by heart. Okay. So when we go to the molecular formula, for the molecular formula, okay, so here we first find, in order to find the molecular formula, we first find the empirical formula. So we first of all, we must find the empirical formula, okay, using the table that I just showed you. And then after that, then we must find N. Okay, then we must find N. Then we must find N and we multiply N on the empirical formula. Then we multiply N on the empirical formula. So we use the we use the formula below. The formula below. Okay. To find n. Okay. So we take n and the empirical formula is here, the EF. Okay. EF, which is the empirical formula, and then we say equals to m, the molecular mass or the molar mass. So in order to find m, if we were to make m, in order to find n, then we must say, then we can divide here. We're going to say the molar mass, the molecular mass, divided by EF. Okay. EF here is the what? The empirical formula. So we take the masses here for the empirical formula, and then we multiply with, so we divide the molar mass here by the empirical formula in order to get the n. Okay, so now again, another important thing to notice is that this formula here is not given on the what? On the formula sheet. Okay, you have to know it. So it comes with practice. Don't worry, we will do. I will show you how you use the formula when we're doing examples, okay? And then now, guys, the other important thing to notice about the table, okay, is that the simplest ratio can be inside the table or it can be outside the table. So sometimes the simplest ratio is inside the table here. Sometimes it is outside the table. Okay, and you have to know when is the simplest ratio inside the table or when is it outside of the table. So we use multipliers. Okay, there are some things that are called multipliers. Okay, these things will tell you whether the ratio will be outside or inside the table. Okay, so the multipliers here that we use, I want to show you on the table here that when the ratio is this, so when we use the multipliers, the ratio becomes outside the table. Simplest ratio and the multiplier that we use. The multiplier. So if the simplest ratio happens to be anything 0.5, okay, so 0.5. So what does this mean? It means that if your simplest ratio is anything 0.5, so it could be 1.5, 2.5, 3.5, okay, your multiplier is 2. And then if the simplest ratio becomes 0.33 or 1.66. Then your multiplier is 3. Okay. So these things, what they mean is that if your simplest ratio turns out to be maybe 1.33 or 2.33 or 3.33 or 1.66, 2.66, whatever point, if your decimals turn out like this, then you use a multiplier of 3. Okay. And then if you have 0.25 or 0.75, you use a multiplier of 4. And then if you have 0.2 or 0.8, then we use a multiplier of 5. Okay. Some of the cases are common, but some of them are not so common. So I will show you. So the thing that we should know here is that what? Is that every time you use a multiplier, then the ratio will be outside the table. So, okay, let me write down here. Let me write it down on the side here, okay? Because it's important. So every time we use a multiplier, then the simplest ratio will be outside the table. So it's very important that you know this. So if the simplest ratio turns out to be one of these 4 cases here, then it means that in each case you have to use a suitable multiplier. You see, so that you get a correct ratio. So I think that let's leave it here for lesson 3. Let's leave it here for lesson 3, and you can leave your questions in the comment section. So in the next lesson, we're going to do examples, okay, where we're calculating the empirical formula, the percentage purity, and the percentage yield. Okay, so I hope you tune in for lesson 4. Let's leave it here for lesson 3, okay? I hope it was helpful. You can take the notes down if you think they will be useful for you, okay? So, yes, let's leave it here for lesson 3. I hope you tune in for lesson 4. Bye-bye for now.